All right, now let's check the different types of the domains, and let's check the angles and degrees of these domains. So far, we have learned that electron domain means the electron locations. We know that a single bond is one domain, double bond, also triple bonds, they are also one domain. Also non-bonding electrons, they are also one domain. So let's start with the species with two electron domains. First of all, you need to be able to draw the Lewis formulas of these covalent molecules. Just so you remember that beryllium is an exception, so it has only four electrons in the outer shell. It doesn't have to complete octet. We know the exceptions are bore, beryllium, lithium, aluminum, hydrogen. They don't have to have eight electrons in their outer shells. So let's take a look at the central is beryllium. We have two domains. Do we have any non-bonding? No non-bonding electrons. By the way, in here for the Lewis formulas, we have to include these ones too. So let me add. As we don't have any non-bonding electrons in central atoms, nothing will repel these electrons, bonding electrons. So the angle will be 180. Let's take a look at these carbon. Also, we have one domain and two domains. Again, as we don't have any non-bonding pairs, there is no repulsion between these two because they are far away from each other. So again the angle will be 180. So we can have two central atoms in here. This one can be central between these and these. Also, this carbon can be central between these and this. Also remember that whenever you see a carbon atom, it always goes to the middle. It should be in the center, carbons. In here, you see we have one domain and two domain. Triple bonding is also one domain. So the angle will be 180. Also, the angle will be 180 because again, we have two domains without non-bonding pairs. These are called linear molecules, and the angle is 180 degrees Celsius. So what if we have three electron domains? Let's say boron, one, two, three. This is three electron domains. Now we see that this circle should be 360 degrees Celsius, but the one between the two hydrogens 120 degrees Celsius. Also, this is called trigonal planar or triangular planar. It doesn't matter. You can also write it like trigonal planar, molecular geometry, and the bond angles are 120 degrees Celsius. Also, this one too. You see, again, this is trigonal planar. We don't have non-bonding, so the molecular geometry will not change. Also, molecular geometry is triangular planar. Also, the bond angle is 120 degrees Celsius. Remember, whenever we have non-bonding, whenever we have zero non-bonding electrons, like in this example, for example, in this angle, electron domain, and should be equal to molecular domain name. Because of non-bonding non-bonding electrons, the molecule will not change its direction, especially the terminal atom. So and they will have the same name. But one issue, one main thing in here. Remember, in the few slides ago, we have learned that multiple bonds they are more repulsive than single bonds. So let's check this case. As we can see, we have it should be 120 because this is we have three electron locations. It's trigonal, but because this double bond is stronger than the single bonds, they will repel. They will repel these hydrogens. So the angle will go down from 120 to 118. Just so you know that because of the double bonding, the degree the angle decreases from 121 to 180. And now let's check this trigonal three electron domains. This we have three electron domains. So electron domain is called trigonal because we have three. But as we have these non-bonding electrons, what will happen to the shape? The shape will change. Why the shape will change? Because this one will start repelling this one. So the molecule in 3D, it is not like that. Let me draw these ones. So it's not like that because of these. Sorry, let me erase these two non-bonding. So it's not gonna be like that because of these two electrons. They are repelling these two. And you see bond angles should be 120 degrees Celsius in trigonal planar, but as we have this non-bonding, it automatically decreases by 3 degree. And you see the shape, it's called bent or V shape. You can say V shape too or bent shape too whenever we have two atoms. And if the shape is like that because of the non-bonding, it's gonna become V-shaped molecule. And let's discuss lastly the four electron domains. Whenever we have four electron domains, you see the molecule is called tetrahedral. By the way, if you remember, this one is coordination bond. This one is coordination bond, but these ones are the normal covalent bonds, intramolecular bondings. So far, we know that in linear, it is 180 degree. In trigonal planar, it's 120 degree, exception the double bonds, it can get 118. But in tetrahedral, whenever we have tetrahedral domain, it is 109.5 degree. So you see, in tetrahedral electron domains, electron domain geometry is tetrahedral. Also, molecular domain geometry is tetrahedral because we don't have any non-bonding pairs in this example. Also, no non-pairs, but let's check this example. As we have, this is tetrahedral domain, by the way, but we have these non-bonding electrons. So what will happen to the shape? As I already did in the previous slide, the shape will change. This one, hydrogen will come to here. Even though the electron domain is tetrahedral, the molecular domain will change because the molecule shape will change. By the way, these dots means that it's going toward the on the opposite direction, and this means this hydrogen is coming toward us like a 3D. So what this molecule looks like, let me draw it. You see, it looks like a pyramid, yes? So the name of this molecule is trigonal, the shape of this molecule is trigonal pyramidal. Please don't forget that. And once we have this, you see in a normal tetrahedral, it's 109.5. But once we have this non-bonding, it decreases by 2.5 degree, 107. Let's say this example, water, we have two lone pairs. So if it was all bonds 109.5, if we had one non-bonding pair, it becomes 107. You see it decreases by 2.5. In here we have two non-bonding, so it's gonna decrease 2.5 more. The angle should be 104.5. So and you see it's like a bent shape, and the approximately angle is 104.5. So, for summary, just remember that we have to, in order to know the shapes, we have to draw the Lewis formula, and we have to see all the electron domains, count the total number of all electron domains. If we have two electron domain linear, if we have three electron domain triangular planar, and if we have four electron domains, it's gonna become tetrahedral. Also, based on the non-bonding bonding domains, we can determine the molecular domain and electron domain. Also, we have to consider the extra repulsion caused by the lone pairs. Also, double bonding. And I believe that's it about Vsepr theory. Please work on these at home, these questions at home. Thank you for listening.